Okay, so we're going to look at telemetry and getting a tip speed calculated from the ERPM from a Tekko32 ESC into OpenTX. So we've got my model here, WeLoser. It's just set up on the bench next to me with its wheels off the ground and safety bar in, but it's powered up, so yeah, it's bound and should be getting telemetry from the Tekko32. So first of all, let's go in. See, we're just hitting right there on the stick, just to get into the configuration for WeLoser. So we're just going to go across all of the pages until we get to telemetry. So you can see we've already got a bunch of telemetry coming in. I'm just going to wipe this out, delete all sensors, just so we're starting fresh. Okay, so it's all sensors.
Low battery.
Yeah, all the sensors gone. And we're just going to discover new sensors. Okay, and so we've got a whole load of data now coming in from the Tekko32 ESC, including the one that we're interested in, which is this ESCR, which is the ERPM, the electronic RPM from the ESC. So, okay, we've got that. That's great. So there we go. See all of our sensors listed here. If we go into ESCR, I'm just going to edit that. So by default, what this is going to show is it's going to show you the ERPM of your ESC, which is different from the actual RPM that you'll see at the motor. So the actual RPM will be the number of poles that the motor has divided by 2, and that'll give you your divisor that you need to divide the ERPM by in order to get the actual RPM of the motor. So you can see here, blades, poles. So we changed that there to 7 because the motor that I've got in WeLoser is a 14-pole motor, so we need half of that, which is 7, and that should give us the actual RPM of the motor coming out as this ESCR value. So we've got that. You're just gonna have to believe me that that's okay. I've got another video that shows it working. Yeah, okay, that's it for now. So if we want to get a tip speed from that RPM value, it's just a simple multiplication, because you're just going to multiply your RPM by the circumference of the swept circumference of your weapon tooth. Will give you like the distance that the tip travels in a minute. You multiply that by 60, you get the distance that the tip travels in an hour, and then you can, as long as you've got the right units, you can create from that a tip speed. I'll put a link to a spreadsheet for actually calculating that value. I mean, it's pretty straightforward, but spreadsheets makes it nice and easy. So in order to get the tip speed, to get a tip speed telemetry value, what we can do is we can just make a copy of that ESCR telemetry value. So if we take that ESCR value and we copy it, so there we go, there's our copy. It's also called ESCR, so go into that and we'll just call it something else. So for now, it takes a long time, come on, T, that's around the wrong, no, it is around the right way, okay, cool. And then tip, speed. Okay, so it's now called tip speed. So a unit is currently RPM. We want that to be something else, probably miles per hour. So we'll select that, and we'll just mess with that. And you see that ratio down there. So blades and poles, currently 7. When we change it off RPM, it changes to 0.7. Not really sure why. Probably just something to do with, like, I don't know, maximum values or something. I don't know. But yeah, if you scroll through all of these units, you'll eventually find miles per hour. And then what we need is this ratio. So you see it's 0.7 at the moment. So that currently, like I said before, it goes from 7 to 0.7. The value that you'll get in tip speed will be the same as the ESC R value at the moment, if you leave that at 0.7. So what we want to do is we want to multiply that up. Again, I'll send you a link to the spreadsheet. But yeah, basically you want to put into that ratio value there, the number that the spreadsheet gives you, and that will give you a new sensor value, which will be the tip speed of your weapon, assuming that the ERPM actually matches what your motor is doing, which in some cases it won't, but it's a decent estimate. So hopefully, your ratio will probably be something quite large by comparison to 0.7. At least with my robot Wheeloser, it's somewhere around 74, 75, something like that. So it'll be a while just going through the ratio like this. But yeah, and that's pretty much it. That's how you set it up. Then once you've got your tip speed, you've now got this new telemetry value that you can use in a screen. So yeah, it's quite straightforward. I'm not going to go into that in any detail, but yeah, in your in the display menu, you can set up a screen, and you can see here we've got a bunch of different telemetry values being shown, and yeah, you can just you can quite happily just switch between all the different telemetry values and input values and all kinds of stuff. So yeah, you'll want tip speed there. Cool. So hope this has been helpful. And that's it.